Today I'm making the walkthrough video for the Challenge 2 in the AI class. This is our slot car, how we developed it, the AI for it, how we got the training data, how we deployed it, and any considerations at the end. So I think we'd like to look at the documentation here and talk about how it was wired. Well, I think first we could look at the report. So to first set it up, we used two microcontrollers, the ESP Room 32s, accelerometer, a motor breakout board for our 12-volt DC motor, and then it's all supplied with 12 volts from the track. We were going to add a battery, but we didn't have time to set up that circuit. We might add that in later, just for fun, after the class is done. And then for the wiring of it, we have the wiring for the motor driver, the sensor. I'm sure you don't want me reading out every detail. So first we wrote some basic code to just test out the motor and it running on the track. So we were able to control the speed and just output a voltage on that to get it around the track. Then we also wrote code for testing the sensor, where it will collect data constantly and compile that. After that, we put them together and were able to run them both at the same time in a combined code, where we could run it around the track at a set speed and collect the data from that for the sensor. And that's what we're going to use to train the AI. So if you have it at different speeds, it'll get different readings on the accelerometer and help that teach the AI about which speeds are good in which areas. So we had to do, we had to write some code for initializing the sensor, and then we put that in a library for the accelerometer and also gave that the function of reading data and calibrating. Our calibration takes around 12 seconds. It's a little long compared to the other groups. So the reason we're using two ESP32s is we're using ESP32 now, which is where one's connected to the computer and the other one's in the car, and it's transmitting the data that way, just to make it simpler for us. So I want to go over the documentation here. Here's ours on the track right there. So basically for this, what we did was we used Edge Impulse with TensorFlow and wrote the code in VS Code in Python for the AI to collect data, and then that data was trained using the TensorFlow model, and then we had the model and uploaded it to the car. We tested that a few times and we kept adding data to it. We could only record data in around 40-second segments. Any longer than that, it was too big and it wouldn't upload through the ESP32 now. We had a coefficient in the code that could be changed manually. We were going to do to modify the speed scaling on it to try and get it to go faster, but we didn't quite get that worked out there at the end.